and all other participants who are there with us for today's webinar. Today we are going to talk about, our speaker is going to talk about the fire safety for buildings, an overview from the perspective of a structural engineer. And I would like to start with the saying that personal vigilance is the best way to avoid and survive fires. Indian Association of Structural Engineers have taken few measures, few steps in organizing the webinars to make all of us aware of the fire safety. So in line, we already have conducted 2 webinars by the international experts. One was the webinar on performance-based structural engineering, structural fire engineering, does it exist? By Professor Luke A. Bisbee from the University of Edinburgh. And in other continuation, we have the second lecture by on the strategies for enhancing resiliency of modern concrete structures under fire hazard by Dr. Venkatesh Kodur from Michigan State University, USA. And in continuation, today we have the speaker, Ms. Anamika Kadam, with us, who is going to enlighten us, who is going to give us an insight about the fire safety for buildings, an overview from the perspective of structural engineers, taking into account the Indian aspect. So not taking much of the time, so as we would all like to listen to our speaker for today, I take this opportunity to introduce the speaker to all the participants. Ms. Anamika Kadam is having an experience of more than 25 years, and she's actively involved in construction management of large-scale infrastructure projects, both nationally and internationally. She's well-versed with all Indian, British, AASHTO standards. Currently, she's serving as DGM in L&T in Phase 3A expansion project of Delhi International Airport, New Delhi. Being an active member of many professional bodies like ISWT, IRC, CAI, ICI, ICI UK, and has also authored a number of published articles related to the construction industry over all her years in this construction industry. She's worked as a civil engineer in overseas projects in Abu Dhabi, UAE, Salah, Oman, and she's closely interacted with international consultants like AURP, Hill Internationals, Larsen, and among others. She's very proudly, she's a governing council member of Indian Association of Structural Engineers. With this very brief introduction, I welcome you, ma'am, and I would now hand it over to you for your presentation. The floor is yours. You may please unmute and share your screen.
Yeah, thank you very much, Shilpa ma'am, and good evening, everyone. Let me start my presentation today without much ado to it. First of all, let me explain you that this presentation is regarding fire safety and fire perspective. What as a structural engineer and as a field expert, we work at site and we see what are the safety measures we take in various buildings. But I will not try to overdo because we have listened, as Shilpa ma'am has already informed us, that 2 of our earlier webinar were more subjective and technical about the subject. I will be touching the subject of fire safety in a very layman term, so that a person who is not expert from the field, who is not fire expert, who is not mechanical expert, can also understand like a structural person who is designing or at the site executing buildings and other structures, can also understand that what kind of safety strategies as far as fire is concerned are being taken care while we design and while we pursue such buildings. So let me start my screen. Yeah, I will be talking about fire losses, what are the building codes and what are the design approaches, and what concrete give benefit as far as fire resistance is concerned, what are the costs associated with concrete construction when we design it as fire resistant building, and what actions we should take, and then list is about conclusions we will be talking about. So, what is fire safety? Fire safety is the set of practices intended to reduce fire, to reduce the destruction caused by fire, and in terms of building design, it is a vital component of building safety. Fire safety measures include those that are intended to prevent ignition of an unconditional fire, and those that are used to limit the development and effects of a fire after it starts. So we should, what are the proper uses of fire protection measures we should take? We will be talking about all those things. When we talk about fire losses, more than 4,000 people die in fires each year, with one death every 130 minutes. Friends, fire kills more people than all natural disasters combined. Approximately 85% of fire deaths occur in homes. Fire strikes approximately 86,500 apartments, 2,000 hotels and motels, and 740 dormitories annually. Each year, fire departments are called to more than 1.7 million fires, with a fire call received every 18 seconds. There are nearly 510,000 structures fires each year, with one occurring every 62 seconds. Fire causes more than $11 billion in property damage each year, which about $9.5 billion resulting from structure fires alone. Half of the property damage also occurs through these fire accidents. So when we talk about fire loss, then we should also look upon, there is an organization, International Association of Fire and Resources Services and Rescue Services. As per report of this organization in the year 2020, it quoted that if we see the trend of the fire deaths across the world between year 2014 to 2018, then the data is very alarming here, which we can see that India, the average death per year in India is maximum, that is 16,714. And if we take that how many deaths occurred per 100 fires, then we can see the lowermost two countries there, Nepal and Taiwan, at serial 19 and 20, where the deaths were in the tune of 7 to 8 people died per 100 fires. So we can see that USA, Russia, Japan, all these developed countries also are in the list. Great Britain, France, Italy, all are in the list of when we talk about the deaths due to fire. So first, let me give brief idea that when building and fire codes are both state or jurisdiction specific, and when we say that it is designed for any particular requirement, say it fire, then the codes give the minimum requirements for any particular structure. So what is a building code? When we talk about its fire resistance or anything, a building code is a minimum acceptable standard used to regulate the design, construction, and maintenance of buildings for the purpose of protecting the health, safety, and general welfare of the building users. So when we are talking about up-to-date building code, as far as fire criteria is concerned, then building code is nothing but it is a set of rules that specify the standards for constructed objects, which may be building or non-building structure as well. Building must conform to the code to obtain planning permission. Usually that may be a local council. The main purpose of the building codes is to protect public health, safety, and general welfare as they relate to the construction and occupancy of building and structures. The building code becomes law of a particular jurisdiction when formally enacted by the appropriate government or private authority. So when we are saying that our building codes are up to date, then it must ensure safe building. It ensures a reduction in deaths, injuries, and property damage is reduced, and it preserves the built environment. It reduces public and private disaster aid. It maintains employment and businesses. Level playing it when we are saying our codes are up to date as far as fire practices are concerned, then it gives level playing field to engineers, builders, and suppliers. It gives economies of scale. It maintains quality of life, and property values are escalated when we say that our building is fire safe. So in Indian scenario, we use NBC, National Building Code, and in India it is the as per the code, fire prevention and fire protection is a subject of the state, and it is the key responsibility for fire protection and fire prevention which lies on the shoulders of the state government. The fire safety rules for the prevention and protection will set in form of municipal bylaws or state regulations as per NBC. Now, I am quickly touching the fact of this, the basic parameters which we consider in design when we design our structure for fire resistance. Balanced design approach we take. Balanced design, we establish the importance of passive design, including compartmentalization in combination with active design to deliver a more comprehensive fire protection system. So in a very simple term, what is active fire protection? Fire protection systems that must be activated to perform, such as sprinklers or smoke detectors, come in active fire protection category. What is passive fire protection? Fire resistance provided by those elements which inherently resist fire, such as non-combustible precast concrete and masonry structures. These gives us passive fire protection to us. So what is balanced design? When we utilize both aspects of in our construction, in our design, that is active and passive, both aspects of fire protection are amalgamated and used in a cohesive manner, in such a manner that it gives compartmentalization to greatly enhance fire protection at a minimum cost. Then such design is known as balanced design. So in a very simple basic rule, if we talk about balanced design of total fire protection, then we utilizes active fire protection and passive fire protection both to give us a total fire protection. So what are the examples for active fire protections? These may be smoke detectors, maybe sprinklers, duct detectors, and fire alarms. All are comes in the active fire protection category. And when we talk about passive fire protection, our fire rated walls, fire rated floors, fire rated separations, which we design as a structural element within the structure, all known as passive fire protection enhancers. So what does compartmentation do? Compartmentation acts to contain fires to a specific area of the building or structure. With compartmentalization, a fire doesn't spread from one room to another room or from one building to another building. So what is the role of sprinklers? Fire sprinklers must act and activated to extinguish fire after a specified temperature is achieved in the upper gas layer. Accordingly, fire sprinklers are designed in buildings. And we design sprinklers as per NFPA standards. There are NFPA standards, NFPA 13, 13D, 13E, 13R, which are utilized for the sprinklers. And why sprinklers may fail in any particular building which we have designed adequately. So there may be a lot of reasons. Some are listed here, like in case of natural events, earthquake, tornado, etc. In case of terrorist event, when the water pressure is inadequate, or there may be human error involved. There may be lack of maintenance, or maybe installation error itself, wrongly designed sprinklers for the type of occupancy or the fire. Coverage issues may be there, or building may be under construction category, and sprinklers, and there may be event of fire, and then sprinklers actually were not activated at all till that time. So there may be a lot of reasons where sprinklers may also fail. Okay, what are the options for us for non-combustible construction? We can use cast in place or precast concrete elements. We can use hollow precast or hollow core concrete elements. We can use masonry walls as a non-combustible construction ways to achieve non-combustibleness of the structure. There are advantages to developers, to communities, to the inhabitants when we say that this is particular construction is non-combustible construction. So first we talk about owners or developers. What the advantage is as an owner I'm getting is that I get the speed of construction. The faster sales and resales value are achieved, and operating cost is lower, insurance cost is also lower, and maintenance cost lower, energy costs are lower, and there may be I have listed here so many benefits. It appeals to investors more. It gives us proven performance, and it is resistant to seismic and high wind damage as well. So what advantages we get when we are talking about as an occupants from non-combustible construction? Fire safe non-combustible construction. We will not get burned. It will not produce smoke, fumes, or gases. It will not add fuel to the fire. It provides minimum 2 hour separation between units. It gives better chance of survival. It gives lower insurance cost, no need of further testing and inspection, no bouncy or creaky floors, superior acoustic qualities, security for occupants and contents. So when we talk about communities, what advantages we get for communities at large? Lower risk and exposure for fire services, more efficient use of fire services. Construction does not add fuel to the fire. Fire is contained. Adjacent units are protected. Structural collapse is unlikely. Provides quality community asset for many decades. Community recognized for its fire safe construction. Provides a stable tax base for the community. Attracts long-term investors to the community. Now again, let me explain fire containment. Fire containment is actually the last line of defense when sprinkler is failed. To be effective, walls and floors or ceilings provide compartmentation should be of non-combustible construction with at least 2 hours of fire resistance, so that fire can be contained. How do we ensure firefighter safety? A concrete structure can utilize fire-rated concrete walls to create compartmentation. The combination of concrete column, beam, flooring, ceiling, and wall elements breaks up each level's space into smaller, self-contained modules that minimize the chance of fire spreading to adjacent units. The containment of fire in these small spaces makes entry safer for the firefighter and maintains that building collapse is rare. So in turn, we ensure firefighter safety also by making non-combustible buildings. So when we talk about the fire resistance property of concrete, concrete has good history as far as the performance with related to fire resistance is concerned. Concrete is non-combustible and has low thermal conductivity. It maintains inner cool core which during many fires, and so that it can maintain its load carrying capacity as well. So as we design structure, the structure is designed as a fire resistant structure will be designed for live load, dead load, and fire. So what is the goal we wanted to achieve? We wanted to achieve a structural stability. We wanted to reduce spread of fire. We wanted to experience total burnout, but without collapse. So concrete at elevated temperatures, we can see here that when the temperature is around 420 degrees centigrade, from 250 to 420, some spalling will occur in concrete. At 300, loss of strength starts, and then 550 to 600 degrees centigrade, cement based material experience creep and lost their load bearing capacity. At 600 degrees centigrade, concrete actually will not be functional, and that 900 degrees centigrade is actually we are talking about the flame. So the term fire resistance actually designates the ability of a laboratory constructed assembly to contain a fire in a carefully controlled test setting for a specified period of time. That is term fire resistance. ACI 216 is used to standardize which is a standard method for determining fire resistance for concrete and assembly construction assemblies. And basically, there are 4 methods are given to determine fire resistance of any particular structure. It may be through qualification by testing, or maybe we calculate fire resistance. And there may be third method, that approval through past performance of that particular type of structure, of particular area, or particular dwelling, or particular type of usage of that particular structure. Then the fourth method is we do engineered analysis to define determine fire resistance of the structure. When we talk about the quantification by testing, then most common method utilized is E119 test method for fire test of building construction and materials. So standard time temperature curve is being used for it. When we talk about calculated fire resistance, the fire resistance associated with an element or assembly shall be deemed acceptable when established by the calculation procedure in as set in ACI 216. And plain reinforced concrete bearing and non-bearing walls, floors, and roof slabs shall conform with the minimum thickness criteria as given in this ACI. So what are minimum thickness criteria? We can see here that for 1 hour, 1.5, 2 hour, 3 hour, or 4 hour fire, for various aggregates, the thickness of the particular element is given here. So we can see that here lightweight or semi-lightweight concrete element are having better fire resistance in terms of thicknesses and give less structural cost than siliceous or carbonate aggregates. We can see here in this table as well that effect of aggregate and the choice of aggregate directly actually impacts the performance of concrete during a fire. So we can see that there are many countries where we see that old structures were made of wood, So fire resistance of wood is very, very low than concrete. And we can see in this graph as well that any concrete wall will bear fire at least up to 4 to 5 hours. But in comparison to wooden frame walls can only stand 1 hour of fire. Also, we can see that if we talk about the performance of the wooden structure at elevated temperature, then strength of the wooden structure falls very sharply, which we can see here. And if we talk about concrete structures mixed with different aggregates, then we can see that structure almost perform at its 100% strength at elevated temperatures till 600 degree Fahrenheit as well. So when we talk about fire spread, if there is a concrete structure, it will not ignite. Fire spread is slowed and its damage is also minimized. Secondly, the ability to resist fire creates more time for detection, evacuation, and suppression, the three key ingredients to minimize damage and injury during a fire. So when we talk about the flame spread, then we can see in wood flame spread like a wild fire. And if we talk about concrete, it is almost flame spread is almost null when we compare it through wooden structures. So concrete limits the flame spread. Now, interior finishes also plays very important role in dwelling units. The majority of fire deaths in a residential home is due to toxic products of combustion from interior finishes. Toxicity. Most fire deaths result not from heat or burns, but from inhaling smoke and toxic gases. So, gases produced in a fire include water, carbon dioxide, styrene, bromide, and carbon monoxide. Concrete does not produce toxic gases when involved in a fire. And if it is compartmentalization is done, then compartmentalization with concrete construction reduces the spread of as. So when we talk about with the balanced design approach, right, safe buildings for occupants, a non-combustible building material that will provide safety and and construction at similar cost to other construction methods. Apart from that, in my current project, we are making will go through. There is one more presentation with me, which I will just a minute. Yeah. So in my current project, which is we are making terminal for GMR. What fire safety provisions we have in a very, very brief manner. I'll try to show to you all. Yeah, let handle large volume of passengers. It is mandatory to ensure that adequate fire safety in airport building. We have standard to provide fire. So as I have already explained that there is active fire protection and passive fire protection. So active fire like
Anamika ma'am, am I audible, Anamika ma'am?
extinguisher or hydrant or automatically.
Excuse me, Anamika ma'am.
Then an integral
Anamika ma'am, am I audible?
yes, yes, you are
Ma'am,
audible. I'm audible.
your voice is breaking.
You are audible.
Yeah, your voice is breaking. I think there is some signal issues.
Hello.
Hello. Hello.
My voice is.
Yeah, your voice is breaking, ma'am. Yeah. The signal is not proper. Your voice is breaking. And it's a request from all the participants, if you can start from the beginning for this presentation, the second part of your presentation.
Okay.
There are some connection issues, I suppose. Your voice is not coming, ma'am, properly.
Yes.
Vikas?
Yes, ma'am.
Yeah, can you please call Anamika ma'am and tell her?
Yes, ma'am. Yes, ma'am. उनको मैं आ गया है, मैं कॉल कर लेता हूँ.
Yeah, sorry from my side. I have changed my network connectivity actually. There was some problem at my end. Am I audible now?
Yes, ma'am. Yes.
Yeah.
You can please continue.
Yeah, please. Once again, apologies from my side. A terminal building design here in Delhi International Airport, which we are creating a new terminal here for GMR. So in airport, actually in every airport terminal building, now I am audible and my screen is shared.
Yes, ma'am. Please continue.
Yeah, thank you. Yeah, so airport terminal buildings handle large volumes of passengers basically. It is mandatory to ensure that adequate fire safety provisions are provided to ensure life safety and continuous operations. The below which we can see here now how we safety provisions are being taken care here. We are utilizing both format of protection here, active fire protection and passive fire protection. Active fire protection can be controlled manually and automatically both ways. So for manually, we are utilizing extinguisher, hydrant, etc. For automatically, we are utilizing sprinklers and gas separation system is being designed as a mode of active fire protection. As far as passive fire protection is concerned, an integral 3-component like structural, fire protection and fire safety in a building, that is fire rated walls, floors, doors, etc. are being designed here so that passive fire protection can be given. So when we talk about three key approach for fire safety provisions, then there comes firefighting features. There is a fire command center. There is a remote annunciation panels are placed. Fire escape corridors are being designed here. When we talk about occupant evacuation management, then power is nothing but passenger address system, voice communication system is being designed here. Exit staircases are planned adequately, and fire escape corridors are there. When we talk about smoke spread management, then fire rated staircases and fire escape corridors are being planned here. Pressurized exit and access corridors are being made. Smoke extract system is placed. Lift lobbies are there. Dampers like fire smoke, fusible link, motorized smoke ventilation, all those systems are in place here. So what codes we are utilizing in this project? We are utilizing NFPA for fire separation system. We are utilizing NFPA 10, 13, 14, 24, 25. We can see here listed all this, and NFPA 2001, and nothing but not least NFPA 72, that is National Fire Alarm Code. Apart from that, if we there is another important aspect which is gaining momentum nowadays is fire resistant steel. So I just wanted to give you a small presentation regarding fire resistant steel as well, which is given to us by SAIL, and they have actually experimented it, and they have their they are actually system developed for fire resistant steel. So let me start that. Okay. So my screen is there, presentable?
Yes, ma'am. Yes,
Yeah?
yes.
So
Now you'll share the third presentation.
Yeah.
Yeah, that's still going to come.
Okay, still going to come.
Yeah.
Let
We
me
are
share.
able to see your screen, your folder in which you have the three presentations. So
Okay.
presentation has not come up yet. Yeah, now it's there.
Now it's there. Thank you very much, ma'am. So at present, fire protection of steel structures is being met through coating, installation, etc., which is very costly, we can see, because of the labor, shell life, etc. Fire resistant steels are become mandatory in developed countries, and SAIL has developed fire resistant steel as per IS 15103, where the yield strength is 600 degrees centigrade, and which shall not be less than 2/3 of specified yield strength at room temperature. So SAIL has developed in two sections, namely NPB and WPB sections, capable to produce in all sectional dimensions. So if we talk about exposure, then plain carbon steel and fire resistant steel, the comparison is very much explanatory in form of this graph here, that if we talk about fire resistant steel, it gives yield strength much higher than our normal plain carbon steel, and it can be withstand till 600 degrees centigrade up to 5 hours. Then if we talk about the how performances, we can see here that fire resistant steel showed double the time better performance than plain carbon steel under stimulated fire condition. If we see here on the left hand side, this outside view, and if we is undisturbed, and we can see inside view where the fire is already there, but the uses of fire resistant steel makes structure more safer. Critical temperature is PC is 400 degrees centigrade, and for plain carbon steel is 400 degrees centigrade only, and for FRS it is escalated up to 600 degrees centigrade. Now, if yield strength remained significantly higher than the specified level, and no deterioration is observed when it is exposed to fire, when it is fire resistant steel, which we can see here in the graphs. When we compare plain carbon steel and fire resistant steel, that hot rolled section and fire exposed sections, the comparison is given here. The strength parameters for FRS are much more than the plain carbon steel, and at room temperature and at 600 degrees centigrade, both ways we can see FRS performance is much better than any other steel. So newly developed fire resistant steel by SAIL not only met all the requirements of IS 5103, but it has also performed very well under extended temperatures, which we can see here till 600 degrees centigrade. No deterioration in properties of the fire which fire exposed FRS steel. There is no deterioration in properties absolutely. Hence, FRS steel can be reused again after fire. So there is future is very, very promising to all of us, where we can see that there maybe plain carbon steel will be vanished from the scene, and we will be utilizing fire resistant steel apart from our concrete structures. So that's it from my side for today, and I am open for question and answer.
Yeah. Thank you, Anamika ma'am, for your presentation. Ms. Anamika Kadam has very nicely summarized the different nomenclatures related to the fire protection and fire safety. She has very nicely talked about the different building codes, especially the NFPA, that is National Fire Protection Association codes that we have. She's also talked about the balanced design approach for the fire protection and how compartmentalization helps during the fire safety, during the fire, and it can be very nicely used for the fire protection. Also, what are the various benefits of the fire construction? And she's also given us an overview about the different aspects of the fire resistant steel, which was one of the very important questions which was put up by our participants, that they wanted to know about how the fire protection in the steel and what type of the steel should be there. So that has that you have already covered it, ma'am. So, and also you have also given us the statistics. You know, we talk about the various hazards like earthquakes, wind engineering. You know, wind and earthquakes are the two prominent hazards which are already talked about, whereas fire is also one of the natural disaster, one of the man-made disaster, I could say, you know, which is very hazardous, and it leads to a lot of damage to both to the life and also to the structures. So there are some of the questions which the participants have, and I would like to put forth in front of you, and I hope you'll be happy to answer to the queries which I have put. We have the participants from abroad also, from Philippines and Pakistan. Thank you for the to all the participants for participating very enthusiastically, and we have many questions, which is a very good, which is a sign that everybody has listened to your presentation very nicely, and everybody has understood to the message that you want to convey to all of them. So I'll take up the question by Mr. Kamal Parekh. He wants to know about the fire tending loading. He wants to know about the guidelines of calculating the load, and also about the units of calculating the fire loading. If you can please answer to that.
Yeah, actually, in ACI 216, all these procedures stepwise are given over there, and we can utilize, we can go through those codes and can actually, it is very explanatory manner it is given there. and we depending upon the usage of particular building, whether it is for non infrastructure purposes or whether it is for our residential purposes, depending upon the usage of that particular building, like I have shown here in terminal building, how we have designed this particular building, taking loads and other considerations. Accordingly, buildings are designed.
Thank you, ma'am.
And NFPA codes as well.
Okay. Our participant wants to know about the FRR, fire resistant rating in the structural design. So how do we quantify it and how do we calculate it? How do we go about calculating the FRR?
Yeah, actually, all these again, I'll try to give you a brief idea only, because all these parameters are well established in our codes. If we go to NFPA and our ACI codes, all set parameters are given over there. Accordingly, it cannot be, gentlemen, cannot be explained in 1 or 2 lines. We have to go through all those codes, and accordingly we have to design our structure.
But basically what happens for fire rating of any element or material is basically it is tested in there's a standard test procedure, and you test that under the laboratory conditions, under the standard fire curve, and then and also the structural parameters also, up to which it should be able to withstand, like deformation, like stresses and all those things. So under the standard fire, your structural member or element should not all the deformation, all those things should not exceed those limits. So according to that, the fire up to which it exists under the standard fire, that is called fire rating, and basically that is listed in the BIS codes also. So
BIS and ACI also tables are made for that particular fire rating. If it is 4R, 2R, 3R, correspondingly for different elements, for different type of construction, we can use, like I have shown one table, for example, in my presentation, the thickness of the element can be taken directly from those tables.
So basically, after the testing of each material and all those things, you get the fire rating, and those are listed in the standards. So while designing or specifying, you have to take the those things from the standards.
Yes, sir.
Thank you, sir, and thank you, ma'am. So moving on to the next question. Some of our participants want to know about the fire drills and the fire safety audits of the buildings. So fire drills, yes, can be organized with the help of our people in the fire stations in our nearby region. So in a very region we are there, we can contact the fire station, and I think on request, they come and organize the fire drill at your organization. So also they want to know about the fire safety audit. How to carry out the fire safety audit in the government buildings. If you can put some light on that.
In terms of in any particular business,
in any building, in government organization, government buildings, how to carry the fire safety audit.
There are set procedures, guidelines given in NFPA. Accordingly, there are set department, and with the help of local jurisdiction, we can always call authorities to, like we have our ISO certification and all, we can set a regular frequency and the timeline when at a regular interval those fire safety audits happen with the help of our local authorities under set guidelines of NFPA.
See, basically, these regulations are in place. So you have to do the structural audit of the buildings of certain height or certain particular type of occupancy after periodical time period, and then and only then and then that kind of a clearance is required from fire department. So how to do the fire safety audit? Basically, I don't know if there is any standard format, but in any case, you have to check it with respect to the provisions of the National Building Code or the building bylaws in place in that area. You have
Yes,
to
sir.
check according to that,
Yes,
whether
sir.
all the provisions which are required as per the code are being followed or not. Right? That thing you
Yes,
have to
sir.
ensure in the fire safety audit.
Yes, sir.
Okay. Thank you, sir. And moving on to the next question, ma'am. Some of our participants want to know about the FRS steel that you have talked about. They want to
Okay.
know about that. What is the approximate cost of FRS as compared to the other steel? And what are the ingredients which makes FRS more resistant?
Mm-hmm.
So that
Okay.
is what our participants want to know about. I think you've covered that in your last presentation, in which was the presentation of the sale, in which you've talked about the resistance of the steel of FRS is much more as compared to the others.
Yes. With respect to the plain carbon steel, yes, it is more resistant. And but if we talk about the approximate cost and what are the particular elements which we are utilizing here in making fire resistant steel, then definitely I have noted it down, and my, I think, sale counterparts are also here. They will we will come back to you gentlemen, and over deliberating this particular aspects of FRS steel. So kindly leave your email ID so that we can give answers to that particular aspect of FRS steel.
See,
Thank you, ma'am,
basically
and
this,
thank.
yeah,
Yes,
just
sir.
so this particular last part of this presentation actually was added on the request of the sale,
Yeah.
and basically we also can't authenticate the authenticity or that of that information which has been provided to the audience. But yes, we believe that sale has provided us the correct information, and that has been transmitted to audiences. Because we believe that fire resistant steel is a very important for the structural engineers and for the construction industry. So I hope any question related to the cost and other thing, I think audience can also directly contact the sale also.
Yes, sir.
Mr. P. Saravan wants to say something. Vikas, can we please unmute him and allow him to speak?
Okay, ma'am. We'll search his name in the
Yeah,
attendee list. P.
it is with
Saravan.
SP. The notation is put up in the question and answer box. He wants to say something.
Mr.
SP. It is with. It's highlighted in a purple square box with the icon SP.
No, ma'am. No, ma'am.
He wants to clarify
Yeah.
on FRS.
Yes, ma'am. Yes, ma'am. Just.
Yes, please.
Yeah.
Hello.
Yes. Yes, sir, please.
Yes, sir. Myself, Saravanan from SAIL R&D, madam.
Yes.
There are some of the questions was there. Actually, how the FRS is made. It is a alloy design. That is what I want to answer it. Basically, we modified the alloy chemistry and we made better resistant to the fire. This thing. That is the first question. Regarding cost, I think our commercial people will be telling that it is it's costlier than plain carbon steel, whereas it is less than that of the coating what people use nowadays. That's the second question I want to use. And third, there was one question was there whether it is available in market. It's recently developed in 2019 something we have developed, and we have developed in 2 sections. We can give it in all sections if market requires. Because nowadays people use coating with the plain carbon material. So instead of that, we can people want to go for FRS, we can provide it. That's my submission, ma'am. Thank you.
Thank you, sir. And Vikas, Professor B. Bhattacharjee is also answering to the queries in the chat box. Thank you very much, sir, for your quick response to all the queries which have been put up. So if you would like to share your views on this, I request Vikas to please unmute Bhattacharjee, sir, and it will be an honor to listen to you, sir. Good evening, sir.
Good evening. Good evening. Can you hear me?
Yes, sir. Yes. If you can on
Yeah.
your video, sir, it will be on.
Oh, yeah, sure. I'll do that. Let me see if I can do that.
Yeah, it's on the left bottom, sir. Just adjacent to the voice, you have the video option also.
Yeah, I see that. Yeah.
Yes.
Yeah. No, I'm not sure.
Yeah, yes, you
Mic
can
is
please
there.
continue like this.
Mic is very much there, but this is, if I understand correctly, they do one of the element in FRS steel is molybdenum. Okay, and coating is a problem. Coating is a problem because coating, you have got coating is a problem because coating essentially means that you'll have a lot of volatile organic compound, emissions. So VOC may come. Many times people don't want to use coating. And then some of the other questions that I was trying to look at into, yes, FRS has been used all over the, many places. Japan, there are, they have all varieties of steel. So FRS has been used actually. And it, I suppose, a good move by SAIL to bring it in the country. If their R&D center, Rachi, good one. And fire resistance, actually, the standard fire is for normal residential building and so on. ASTM fire, 1925. So that's adopted in Indian code also. Simple formula. Temperature of the furnace should be equals to temperature of the ambient plus 345 log 8T. T is in time plus 1. Log of 80 plus 1. So that when T is equals to 0, log 1 is equals to 0. 345. So you subject the element to that temperature regime, and it should not fail by failure by structural failure, that is your deformation as well as collapse, nor should it fail by insulation. That means temperature on the other side should not increase more than 150 on an average, nor 180 at any point. And integrity, no crack should come. If it comes, there's a method of testing it. Put a cotton pad for 10 seconds or something like that, and it should not catch fire. CBRI has got a facility to do that actually. I think Pune, there is another lab who has got. So time is the thing. And I think I put on another one is a fire load. Fire load for different occupancies are given. American literatures they have. Essentially, it is expressed either in megajoule per meter square of the floor area or equivalent kg of wood. So megajoule per meter square divided by the calorific value of wood. That will give you equivalent kg of wood for combustion design and things like that. If you want to find out time temperature within a building. Now there are some softwares which will give you smoke movement and CFD softwares can also do similar kind of fire simulation. CVRI fire group, they have, I suppose, this software. Thank you. Thank you very much for giving me opportunity. I was looking at it because seeing the title, I came to this lecture. Interesting. I do have a course on fire. It's there in NPTEL also, National, NPTEL Building Services Maintenance Management, but that's largely on fire protection, not on structural fire design. But I do cover design, empirical design of steel elements for fire, where it is assumed that at 550 degrees centigrade steel fails because warping would occur, deformations are too much. And concrete fails when the reinforcement attains 550. Very conservative kind of design. But then these days, a lot of people are working on the complete structural performance under fire. Thank you very much.
Yeah. Thank you, Bhattacharya sir, for your inputs. And I think our participants must have gained by this. Coming over to Anamika ma'am. So there is a question. Yeah, thank you, sir. There's a question, how do we calculate the overall fire rating of a building as a whole?
Overall fire rating of a building as a whole.
Yeah, of a building. If you want to calculate the fire rating, if you want to rate a building with respect to the fire, how can we go about it?
Yeah. As per our NFPA standards, we do first compartmentalization of the structure, and then accordingly as per the local jurisdiction for that particular, if it is a hospital building or all, then there are fire ratings for 2-hour or 3-hour fire rated construction need to be there. Accordingly, compartmentalization is done, and accordingly, overall fire rating is decided for that particular building. It depends which area and which kind of dwelling or which kind of building you are designing. Like
Thank
we
you, ma'am.
design hospital for 3-hour fire rating.
So I would like to end up taking up the question and answer session. And if our participants have more queries, we request you to please put your questions to the ISTructy Gmail ID. So where we'll pass on all the queries to Anamika Kadam ma'am, and she'll be happy to answer them, and we'll send you back the responses.
In fact, the design stepwise also.
Yeah. Thank you so much, ma'am. Now I request our President Manoj Mittal sir to please give the closing remarks. Over to you, sir.
Yeah, thank you, Anamika. It was very nice presentation, and you covered a lot of topics. And I hope audience must have got a good idea about fire safety in building from a structural engineering point of view. And I believe that we as a structural engineers should learn more about this fire safety. Of course, some fire ratings and all those provisions are given in National Building Code, and also something given in IS 456 also. So basically, we must learn about the new materials, the fire-resistant materials, and we should use and specify those materials. We should also learn how to do the detailing from fire-resistant point of view. Sometimes we need to provide extra cover. Sometimes we do over design also, over strength also is required from a structural safety point, from fire safety point of view. So there are several. I think we structural engineers need to learn more about this fire safety point of view, because many of the active things like sprinkler system, this and that, those things are being done. But passive systems are very much important, and they contribute a lot to the cost of the construction. So we must learn that, and it will be because in view of that only we had a MOU with School of Planning and Architecture and also with the Institution of Fire Engineers, and we initiated a series of webinars. And so this is basically a third webinar. 2 webinars, as Dr. Shilpa Paul mentioned, we had earlier. So similarly, in future, we will like to have more webinars on structural fire safety. So I'm also very happy that we have good numbers of participants today. So I think this topic is getting good attention from our community. And so it was very good webinar, and it was very nicely conducted by Dr. Shilpa Paul. So thank you so much for everyone, to everyone. And I just also wanted to inform that we also have a half-day course on professionalism and ethics for structural engineering on 11th of February from 3 p.m. onwards. It is free of cost, so anybody can join it. It will be, I hope it will be very good course from ethical. We should learn about ethics and professionalism, whether what is the meaning of professionalism and how ethics is important for us. So that is free of cost. That is a half-day course. You should join it. And also we have another program on 10th of February, I think. This is a webinar on climate change, and it is being jointly organized by our association, that is ISTructy, and also ISTructy, Institution of Structural Engineers UK. So this is a joint activity on 10th of February at, I think, evening, I think around 5:30. Vikas, kitne baje?
Yes, sir, 6 p.m. sir.
6 p.m. Okay, it is a 6 p.m. because we have to match the time, because we have 2 international speakers. So we have to match the time. So it is at 6 p.m. So I'm sure that will also be very interesting webinar. So everybody should register it and join it. I think we must have announced it, or not announced. It will be announced very soon. Yeah, thank you. Thank you so much.
Thank you, Manoj sir. And thank you, Anamika ma'am, and thank you to all the participants. So there are a lot of thanks from all the participants to you, Anamika ma'am. So
Thank you very much to
presentation,
all
the
of you.
webinar has been very well taken by all the participants. And I think from the webinars that we are having on fire safety and the events, the incidents which are happening. So this is a topic which should be very importantly taken also in the educational institutions also. So and at the undergrad level and at the postgraduate level. So there should be a course, at least one, we should have a basic course on the fire safety of buildings for the undergraduate level as an elective course. So that point should be taken up by the academicians, and I'll also take it to my institution so that this is taken up as an elective to the students. So they know about, we keep on talking about the other hazards, but fire safety is also one of the very important aspects. And many
Very
institutions,
correctly
I think,
pointed.
are talking about opening up the diploma, the certification courses on the fire safety. So
Yeah.
looking forward for more enthusiasm amongst we structural engineers on the fire safety of buildings. And
Yes.
thank you, Anamika ma'am, once again on behalf of ISTructI. And on behalf of ISTructI, we would like to thank all the participants, all the experts, all the eminent speakers and others who have participated and spared their valuable time to be with us for this webinar. And in the end, I would just like to say that don't let your dreams go up in smoke. Let us practice fire safety. So thank you one and all for being there.
What a wonderful end to the
Yeah.
this
So
thing.
thank you and looking
Thank
forward to
you.
meet you all in other webinars by ISTructI. So please be safe. Thank you.
Yeah.
So we'd
Thank
like
you
to
all.